Okay, Marie-Jo, can you hear me?
Yes, I hear you.
Okay, I guess it's time to start.
Okay, so welcome everyone. I can see there's 22 people on the Meet Echo. It is 2:31 a.m. in Montreal, Canada. And I can tell you guys that the last time I was up with such a large number of people at 2:30 in the morning, I had been invited to the cast party of a theater play, and actually we had started going out at midnight. So hopefully this is going to be as entertaining as going out with the cast of a whole play. But and I will not put my video. I'm currently in my bedroom, and I don't want to put too many lights outside also, on, because eventually I'll go back to bed. Okay, welcome to this meeting, virtual meeting of Coding for Efficient Network Communications. This is our IETF research group. Obviously, our goal is to, and has been for quite a number of years now, foster research in network and application layer coding to improve network performance. We've done a lot of work in this group in the past years. We've done codes, obviously, in coding libraries, but actually I would say, so we actually have developed codes and codes libraries, but I would say most also important was the goal of the team was to develop protocols actually to facilitate the use of coding in existing system. We wanted to have real world use cases and work in progress. And I think it's important to highlight that this is all in the context of research. So even the protocols and the real world and the coding, we wanted to foster research in that, not just develop codes for the sake of developing code. So there was just looking at what the research in this area was targeting, what were some of the problems that this research was going to address, and how the protocols and the use cases were showing that research was working or was actually delivering outcomes that had been planned for it. Next slide. So this is obviously the intellectual property that we just went really fast with. Now this is the privacy, and well, no, we can, everybody knows that you have to declare your IPR. We've had quite a ride in this group about that too. So next slide, Vincent. Privacy and the code of conduct. We obviously need to behave. Again, very important, I think, is the goal of the IETF. We're not a standardization group. We are, like I said, fostering research. And even when we say, like I said, we develop codes and we develop protocols and things, it's all in the context of the research around this, not, again, in the context of developing a standard. And I think for many people, it is still a struggle, because people think, oh yeah, we're going to take it to the IETF. It's like if we're taking it to the IETF or to another standard organization, but it's not the case. This is research, and I think you're going to see today the presentations. Is it today yet? Yes, it is today. It's not tonight. It's today. Sorry. Yeah, so give me just a few seconds to adapt myself. Where you're going to see that what we're presenting today is about research. Next slide. So we like everybody, like in the IETF, we have a presence on the IETF, in that case, data tracker. And so you can find our charter there, the documents, also all the slides of previous meetings and stuff. We have a GitHub that Vincent uses to post material and actually to post some of the results of hackathons that we've had and other documentation. Obviously, for you guys who are in this meeting, you are aware of the mailing list. I see now that we're 25, which is great. I wonder how many of you are on the East Coast of Canada and the United States. Actually, even in California, it's 11:30. It almost makes sense. So the materials are on the data tracker, and on the GitHub repository. And again, if you go on the IETF meeting, you're going to see that. The session is being recorded and it's going to be uploaded to the IETF109 YouTube channel. We have a blue sheet that's automatically filled. For those of you who never attended an IETF meeting, a blue sheet is stuff that goes around the meeting to see who is participating. If you want to join the queue for questions, please press the raise hand icon, and you're going to join the queue. And Vincent and I are going to monitor the queue. Our agenda is kind of simple. This is me now doing the administrivia. We're going to have a presentation of the BATS coding scheme. This is something that is really advanced and is Ramon Young and his team.
Just to interrupt you. I'm not totally sure about the BATS presentation because I didn't receive any slides from Raymond. I don't see Raymond in the participant list, so I don't know what will happen.
Okay, well, I think they had also said that maybe they would skip the meeting in the last few days, so I wasn't sure if they were going to change their mind. So if they're not there, maybe that means that we do not have a BATS coding scheme presentation, and they're going to rejoin us at the next IETF. But maybe we want to say something about the BATS draft ourselves, where it is in terms of ID and becoming a research group item. So maybe we could just say that for a few seconds. You could talk about that, Vincent. We're going to have a presentation on coding and congestion control, which has been an issue since coding usually hides lost packets or also used to signal congestion. And Morten, who is going to present us repair patterns for sliding window codes. And Morten, I saw your message about being at home with young kids, and I really send my best. Next.
Okay, so maybe I can take over.
Okay, you can pick up from there.
Yes. Thank you. Thank you, Mario. So a few words about the current status of this group and the working items. So we are approaching the end concerning the first ID, network coding for satellite systems. It passed ISG review. Recently, it has been updated based on one final comment we received from ISG review, and well, now the floor in the hands of Colin Perkins to have a final review of this quick update. So it will hopefully be published by next IETF meeting. Otherwise, we launched two.
Hopefully, be published a lot earlier than that.
Yes. You want to say something, Colin?
I was just saying it will hopefully be published a lot earlier than the next IETF meeting.
That's all? Yeah. Okay, so otherwise, we started two calls in September, one for the network coding for CCN and DN requirements and challenges in the drafts, and the other one for the BATS coding scheme. So the first call was the research group last call, which was copied also to the ICNRG mailing list, since it is a document that is shared between the two groups. We didn't receive any feedback from either groups. I sent a quick review yesterday about it. From my opinion, well, the document is in good state. There are a few changes to be done, but nothing really serious from my point of view. So this is something that we need to confirm, of course, with the ICNRG chairs and group, but I think we have something which is quite solid right now. And next step, if everybody agrees, will be to move it to the ISG for review, to continue the process. So that's the situation for this first document. And those document, the BATS, the question that was raised during the call on September was about research group adoption of this document. So we received two messages, one from Colin and the other one from Emmanuel. Their comment was essentially to say that, okay, it's a good document, but probably more on the standardization aspect and less in the research one. So this is the feedback that was sent back to the authors, and the authors updated the document quite recently, yesterday. So we need to decide what to do if we agree to have it be a research group item document, but that's something that we can discuss later on. I don't know if any of the authors joined right now. I'm still waiting for Raymond, but seems not to be here. So I suggest we discuss this at the end of the meeting. I don't know if in the meantime Raymond will be able to join and do the presentation about the BATS new version of the new version of the BATS document or not. But let's postpone it a little bit, this discussion a little bit. Next, sorry. Otherwise, we have this document and coding and congestion control in transport. Good work. That is making a lot of progress. There will be a presentation from Nicola on the topic, so we will see then what the updates that have been made in this document, on this work. And we still have two items in standby mode, I would say, one for the coding for quick and the other one about Tetris. So I suggest to discuss this at the end of the meeting. And we are almost done for this, for the chair slides. Yes, I can say that we still are planning to close this research group mid 2021, so probably after the July meeting next year. This is still the goal, and we'll of course have an IETF network research group meeting, network coding research group meeting for next during next IETF, and hopefully hackathon. I wasn't able in position to do this hackathon, to hold this hackathon this time about the Swift codec, but I hope to be able to do so for next IETF. We have to finalize this this codec before closing the group. So that's for the status. So any comment? Presentation. So Nicola, I suggest we continue with your presentation. Nicola, can you hear me?
Can you hear me?
Yes, it's okay.
Okay.
You have the floor.
Okay. So, hello everyone. This is an update on the coding and congestion control draft we have been working on in the last few months. Just next to me, there are lots of word works, so there may be noise during the presentation. I'm sorry in advance for that. Next slide, please. Since last IETF, we have done lots of experiments and also added a very large discussion section. I will go through first the experiments in this presentation and then go over the whole draft again. But I just wanted to show here, just looking at the table of content, the amount of sections that have been added in the document. Next slide, please. So thanks to the people which names are listed on the list here, on the slide here, we have done some experiments. Basically, we have two different setups. One is using an HTTP over TCP server, and the other one is using QUIC over UDP over IP. We use PicoQuick with cubic congestion control, and we use a Tetris tunnel below the transport layer. Next slide, please. We have three different types of satellite links that I use. We have one that is mobile end users. So this is a use case we have already shown to the group before. So basically, the mobile user is a train, and there are obstacles that are regular. So when you look at the picture on the bottom right of the slide, you can see that we have regular packet losses. On the top, this is something that reflects the losses that could happen with optical links. So this is a huge trend in SATCOM systems to use optical links on the feeder or on whatever length. So to go through these frequencies to increase the data rate. So, but this can come with losses. So there are a lot of work on it. This is a very high level view, but this is something we could see, where basically we have lots of bursts of losses on the optical link. We also have a case where we have a DVB-S2 classical satellite link without any losses. Another thing that we changed during the experiment, and sometimes we use Wi-Fi, we emulate Wi-Fi losses, sometimes we don't, so it's just 1% random losses. And sometimes we just run tests with single flows, and sometimes we just add load with a variable amount of flows to introduce congestion. So in this presentation, I just show partial results. I think the objective is to show why what is in this document is important, and the rest of the results are under submission at the moment. So next slide, please. Basically, I just show one result here when we have the mobile user. We download 20 megabytes, and we have here I just show the median over more than 20 tests. So if we just compare, basically the four first lines use the FEC Tetris tunnel. The four below ones, last ones, do not. So here we showcase with, without Wi-Fi, with and without congestion. What I wanted to highlight, I will not go through the whole details of the results, but what I wanted to highlight is that when we compare what we have with the FEC tunnel and when we don't have it, is that we have a drastic reduction of the 20 megabytes download time. So this is why we could be very happy saying, oh yeah, my FEC solution is the best, It works for both TCP and QUIC, and it's very great. I just also wanted to say that if we look in the details, when we speak about FEC and congestion control interactions, we can see that this depends on the congestion control itself, because here we use the exact same FEC tunnel, but we use QUIC and TCP, and we can see that the results differ. Next slide, please. Here in green, this is the cumulated throughput of the 10. Basically, we have 10 coded flows and 10 non-coded flows. We can see here is in green is that when we introduce the 10 non-coded flows, the amount of the cumulative data rate is the same, but below the flows, 10 flows are coded, 10 are not. So what we can see here is that the rest of the traffic has sees its amount of available data rate diminished. So this is a big problem. Basically, when we introduce coded flows and when they share a bottleneck with non-coded flows, this can have a very large impact on the data rate of the others. So this is somehow what we wanted to mention on the impact of the fairness when you actually introduce coding. Next slide, please. And this is what happens. Basically, this is the same experiment, but we use QUIC this time. What we can see here is that at the bottom, when we have 10 coded flows using QUIC, we can see that the others barely can send any traffic. So this is a very big problem, and this is one of the reasons why we say there can be a lot of unfairness when you actually use coding inside the tunnel, and when you don't consider congestion losses when you hide the congestion losses end to end. Next slide, please. So basically, this experiment shows why we should not speak about FEC without speaking about congestion control. Basically, FEC and congestion controls can be seen as two different things. And FEC could hide, just like Marie-Josée said in the introduction, should hide congestion signals. So basically, this document try to discuss how these two things can coexist, and also encourage the research community to consider congestion control when proposing and comparing fake solutions. Otherwise, they can fall in the same trap as we did, saying we have a fabulous FEC mechanism for all satellite use cases, but then we end up having very important fairness issues. Next slide, please. There are very wordy slides. The intent was to recall the whole document for those who hadn't read it. I realize that I'm only having 8 minutes left, so I may go quickly on that. Basically, FEC and congestion controls can be seen as two different entities. Next slide, please. There's something we didn't discuss before. This is somehow new in the document, is that the relevance of the discussion of the interactions between FEC and congestion control depends a lot on the transport layer itself, because we can use non-reliable transport service or partially reliable transport service or reliable transfer. So depending on how the FEC and congestion controls are scheduled, the impact of reliable transport on FEC mechanism is very different. Next slide, please. There are basically three possibilities. Either FEC is above transport, next slide, please. I think I'll go. This was already presented in the previous IETF. FEC can be within the transport, or FEC can be below the transport. The next slide, please. Next slide, please. And so these, we have introduced in the document different advantages and drawbacks on having FEC above, within, or below the transport. And what we have added is a more wider discussion section on the different, going more into the details. So this is what I will present now. There have been some discussions, and there's always a Pandora box when you speak about policy, fairness, because if we look at this figure, we have two different views. We have the CPE of in the local network on the right side. This one may use a satellite access, and the satellite operator guarantees that there's no unfairness between the different users, satellite terminals. This is the same that could be seen at the UE level in a LTE 3GPP network. Basically, we have we should not have fairness issues when we look at the CPE level or the UE level in a network. That being said, when there are flows sharing the same QoS and the same contracts, then fairness discussion applies. That could be, for example, different applications running on one UE in 3GPP, or the different computers behind one end user terminal at home. So next slide, please. This slide, and sorry for the size of it, I wanted to have everything in the same figure, and basically these are the different themes over which we went through, for discussing the impacts of having FEC above, within, or below the transport. We have looked at the fairness issues, how congestion control uses recovered symbols, the impact of the interactions between the congestion control and the coding rates, and what happens to useless repair symbols. These are discussions and things we had during these things were this is based on comments we had from the list, or when we already presented the documents previously. I don't know, chairs, if I have time to go through the different points here, or should I rather ask for people's opinion on the list? What do you think?
Nicolas, you can take a bit more time, because I guess that Raymond will not show up, and maybe we won't have the BATS discussion, BATS presentation. So
Okay.
if you want to take 5-10 more minutes, I think it's feasible.
Okay.
So.
Okay. Thank you. I will then just go quickly over this. Basically, we think something that comes a lot from this table is that when we look at the fairness and the impact on the non-coded flows, there is an issue for the FEC below transport case, such as we shown earlier in this presentation. We think that this approach can drastically reduce the output for the non-coded flows. But then specific signals can be proposed, such as a testnet that has been proposed by Emmanuel earlier in previous IETF meeting. These solutions could be proposed, but would be then protocol dependent. Another thing, if we look at, for example, something that we think is very important and we would like to highlight is the interactions between congestion control and coding rates. mostly very interesting for the FEC within transport case, because they a very large trade-off between reducing the output when we actually we send useless repair samples, but then this can help to recover fuel from transmission and congestion losses, but still we should be able to propose, in the case of the FEC within transport, signaling to enable receivers to indicate precisely the number of source packets that have been received, the number of repaired packets that were actually useful in the recovery process. And so this, using this receiver may actually be able to exploit the information given by the receiver to reduce the number of useless repair packets. If we look at this table, if I let all have time to read it later after the meeting, but our main conclusion is that for the FEC below transport, there may be lots of issues. We just add loads on the network. There's fairness issues, and we are not aware of the congestion control implementation. So we think this is something that should be either, for the moment, we just describe it in the draft. We don't take position on what is advised or not, but this is something important to consider. Next slide, please. In general, Marie-Josée recommended us to try to come up with open research questions, and indeed there are. Basically, because when we use coding, we reduce the good put when we send useless repair symbols, but then we can help recover from transmission and congestion losses. So this trade-off is always here, but the way you actually can consider it depends a lot on the relation between the FEC and the transport. So if we start with the right column, when we are in the FEC below transport case, the fairness issues that we mentioned earlier on, and also sometimes you may have different streams, multiple application streams sharing the FEC channel. So this is something that needs to be considered because we use the same FEC mechanism for the whole streams. So that may be something that needs to be investigated. In the case of the FEC within transport, we have the room to define specific signaling between both entities. So this is very interesting, and there are already proposals for quick, such as the one from François from Louvain, because we can actually disambiguate the ACT packet from the repeat packets. So we can try to define new signaling methods and FEC recovery-aware congestion controls. Then we could even have dynamic coding rates using another congestion controls, for example, lower than best effort one. But there are lots of things that could be possible in this FEC within transport case. For the FEC above transport, basically, this is mostly all related to application requirements. Next slide, please. Our advices for evaluating coding schemes is to avoid the things we described at the beginning of the presentation, being showing the good performances of FEC mechanisms and ignoring the issues and the impact on the congestion control and the fairness of it. So we propose to map the contribution with the proposed organization of the document. This is very important in our opinion. And there is always an important aspect with that. When we hide a packet loss signal to the congestion control, it is very important to assess the advantages of it, as opposed to just ignoring a proportional accounted losses of the congestion control. That would be a very good bottom line for the evaluations and the performances of the proposals. And also, such as we mentioned earlier on, discuss the impact of hiding losses to the congestion control mechanism. Next slide, please. This is the last one. We have added lots of discussions element, and we think that now we need to reorganize the document a bit. So this is something that we need to do before for the next submission. That's something we have in mind, and the document should be improved in this way. We may come up with some recommendations. I'm not sure, that's not the objective of the document, but when we have written all that in the table of the comparison presented earlier on, we think there may be some recommendations that could be written, but we need to discuss that. And obviously, we are very happy to have any questions or comments on the document. Thank you.
Thank you, Nicolas. Questions, comments from the audience?
I have one, but it's not as the chair. Nicolas,
Yes.
this is important work because as people who've been involved with coding for a long time know, the congestion control always comes as a problem and as one way, in fact, of dismissing the use of FEC. And what you showed, yes, if you go through with your coded stream, everybody else, falls back, and sure, you think your coded stream works perfectly, but it's because everybody else lost their bandwidth. So this was interesting results. But and again, as we also consider coding for quick, it's also very important. So you said, in the avenues for research, do you know anybody who is doing the research, or it's just avenues now? Well, besides you doing the research, or the authors, do you think this has been picked up by other people?
We know there may be some interactions with what's going on in the loops working group, but it's still not a group. We think there is interest in these discussions, but we haven't had formal feedback from other people working on that. We know there are lots of people working on FEC mechanisms at the transport layer, but we don't know if they actually are interested and if they actually are looking in the draft. We are in the process of adding a state-of-the-art section where we listed all the articles, research articles, with this kind of discussions. But we are actually in the moment listing who is working on that. That's something that we have on the to-do list for this document. I should have mentioned it, but still not. We could not sort all the papers in time for this meeting, but this is something we plan on doing for the next version of this document.
Okay, thank you.
It can be quite ambitious because sorting all this work being done. You think
we don't plan. No, we have started to list some papers. This is on the GitHub for anyone who wants to look at that. We have started
Okay, I think we have a problem currently, Nicola. We have no feedback, no audio from you. Yes, I think it's a general issue, but the chat is still working. Can you hear me? Can anybody hear me?
Yes, I can.
Okay, so it's more on the Nicola side than okay, which is the
Yeah, we have
good point. Yeah.
we have 2 people in the queue too.
Okay, okay. People in
I
the
had to go to a
queue.
different network to reconnect.
Maybe you can switch to next presentation. I cannot hear Nicola anymore.
People in the queue, maybe you can post your question on Slack. I think I created the network coding research group channel on Slack. If you want to post your questions there, Nicola could see them there and answer them later.
Can we avoid adding another communication channel?
I will not comment on that, but I did create them, so we can use them. So there is a network coding channel. So if you want to post your questions there, at least I'm going to be able to capture them and send them to Nicola if he doesn't.
I'm back.
Oh, you're back.
Yes,
Great.
Excuse me.
So there were 2 people in the queue, Nicola.
Okay.
Karsten and Morten.
Yeah,
So Morten, you want to add your question? You ask your question?
Yeah, thank you very much. Nice presentation, Nicholas. I agree. This is important work to be done, right? So there's one thing that maybe I don't understand, or maybe you can clarify a little bit. So when you say coding above the transport, to me that doesn't sort of that wouldn't make that much sense, because if you have something like TCP underneath, which is doing retransmissions, or QUIC, which is doing retransmissions, you wouldn't really see any losses above the transport unless you're running like on top of something, like directly on top of something like UDP, for example. So can you maybe clarify a little bit what you mean about coding above the transport?
So thank you for your question. This thing, by coding above transport, we mean coding at the application level mostly. I agree that this does not actually make sense when the objective is to discuss the impacts and the interactions between congestion control and FEC. At the moment, we have added it just to be sure that we discuss all the cases, below, within, above. And in the document, I think that we say what you just said. We agree on that, basically saying it doesn't make sense if you are above TCP. And basically, UDP is the most relevant case for the transport in this scenario.
Okay, makes sense.
We agree on your point, and this is what I think. At least that is what we tried to put in the document. If it's not clearly said, we may have another pass on that.
No, I think probably the document is fine. I was just paused until the presentation, so I'm pretty sure that if it's written in the document, it should be just fine. Yeah.
Thank you.
Karsten, you had a question?
Yes. So the effect you showed at the beginning of your slides is not the result of adding FEC, it's a result of hiding losses from end-to-end congestion control. And that is how you are doing actual harm, and you shouldn't do harm. I don't know if you have read Ranisha Ware's paper 1 year ago from Hotnets 2019, where she examines the concept of fairness and actually suggests replacing it with the concept of not doing harm. She will present that on Friday in the IETF Open meeting because it won the ANRP prize. I think that's a pretty good basis for continuing with the work, because the term fairness may not be a very useful term, as we have found out in like the last 25 years. But what I really wanted to comment about is that you are missing a column. Your category FEC below transport really should be called FEC disconnected from transport. I think what most people who work in this space agree is that FEC actually has to do some signaling to the transport. And this is probably a more interesting column than the column where you don't have any signaling at all. Of course, if you integrate FEC into transport, then you have that signaling implicitly, so that the FEC can talk to the congestion control in the transport. But if it's done by different entities, as I understand was the case with your Tetris tunnel, then you have to do some signaling. And then, of course, the interesting question is, how do we do the signaling? And I think that's an area where the interesting research questions are. So the first question is, how do you actually send the signal? And so far, the only way we have found is using ECN. So you use something like CE marks to indicate that the packet was recovered and not did not make it originally. But I think the more interesting question is how much can you actually minimize harm by doing this signaling? So do you really have to completely emulate the situation where all losses are indicated as congestion periods, or whether you actually can do a more intelligent form of that signal? And that's really the kind of research that I would like to see, because the FEC layer, of course, has more information about this, and it would be good to relay some of this information to the congestion control. And the problem, of course, is that congestion control may actually not be aware of the whole thing going on. So you can only talk to it in the languages it understands.
Thank you for these comments. On the first part, I have read the paper, and I think we could indeed include that in the draft. We just wanted to also, we were not sure on to what extent we should open the Pandora box on fairness in this document, but it is true that this is something we need to discuss. We wanted to, if we look at slides 14, we also wanted to mention, because sometimes when fairness is discussed with a typical dumbbell architecture, that's not actually what we have deployed today, because we have actually lots of quality of service mechanisms that guarantee fairness between users. So this is something that needs also to be discussed when we speak about fairness. And this is very a policy concern, so this is why we referred to Bob Briscoe's work on flow rate fairness. And that also, I think, the definition on not to harm others is something we tried to map in this presentation. But we may make this link more formally in the next version of this document. I would tend to disagree on when you propose to say that when we have the FEC below is the FEC disconnected, because we mentioned the case of the TETnet and all these things where we actually can have a signaling between the FEC and the transport layer. We just mentioned that this is protocol specific and this cannot be done in general. And so I think indeed I would agree with you two research question. I think the one on improving the quality of experience while guaranteeing fairness to with other flows is something we are currently covering. The definition of signals for the fact below transport case may not, so this needs to be more clear in the document.
Thank you.
Thank you.
Okay, thank you, Nicolas. We are a bit short of time, so it's now time to switch to the next session. Sorry. I will stop. I have, yeah, it's coming. Okay, I have a small problem sharing. Okay, it's up. Morten, you have the floor.
Thank you very much. I hope the audio is going through well to everybody. So I have a short presentation here on repair patterns for sliding window codes, and this really came about because we were doing a couple of projects where we were working on very low latency applications, so in an end-to-end fashion. And working on those applications, we learned that our intuition about how to produce the repair wasn't really correct. So I would like to sort of spend a few minutes presenting our findings here, and maybe get some feedback from you guys on what if you have some views on this. So if we take the next slide, just a brief background, right, for those that may not have seen sliding window codes before. But most people are probably familiar with the traditional block codes. So what we have there is basically we have a set of packets, and from that set of packets we produce some amount of repair, and then we have another set of packets and we produce repair from those from that, and we call those set of packets a block. And in this specific case, we have 4 packets in every block, and we produce 2 repair from every block. So that's most FEC codes can operate, or erasure codes can operate in this block mode. But sort of in recent years, we have also seen a bunch of implementations that are looking more at something called sliding window codes, where at the figure at the bottom you can see sort of in the dashed line the coding window, and it's sort of packets are not sort of grouped into individual blocks, but packets are flowing through the same coding window, and at any given point in time we can decide to generate repair for the packets that are currently in the window. This window can then be managed, for example, in time. So you can say like packet number 1 is going to be useful for 80 milliseconds, and if that's how long I can continue to include it in my encoding. And once it's sort of above this 80 milliseconds, I just drop it from my encoding, and if I haven't decoded it at that point in time, I also have to drop it on the receiver side. Those types of protocols can be quite useful for low latency applications. I'm not going to go too much into that, but they basically can be used to minimize latency. One of the sort of interesting questions that come about is that when you use these protocols, you typically have some packet loss that you want to overcome. It can be that you're observing, let's say, 5% packet loss, and you want to generate repair to fix that packet loss in advance, right? Because it's a low latency protocol, you don't really want to use retransmissions, because there you have to go back and forth over the link. So that might be okay if it's a low latency link, but if the link is expensive from a latency perspective, it might not be okay. So how to generate this repair, what is the best pattern, is a question that we sort of had to answer. If you take the next slide. So here we have two different repair patterns, and on the left, what we have here is symbols coming in. So S1, S2, S3, S4, so forth. They're symbols that's basically equivalent to a network packet. It can be from a video frame or something like that. And then what we do is that we can generate this repair, which includes some of these symbols, right? R1, R2 are including S1, S4. And what you have on the left and on the right is two different repair patterns. On the left, we have a 4,2 repair pattern. So we take in 4 packets and we generate 2 repair. Then we take 4 more packets and we generate 2 repair. The coding window in this case is 8. So you see that the blocks or the coding windows are overlapping, right? Which is different from a block code. But actually they produce the same rate of repair. So all of them produce 33%. And on the right side, we have a 2,1 repair pattern where we generate 2 packets and then 1 repair, 2 packets and then 1 repair. And if you look at at a column, you will see that every symbol is covered by 4 repair packets. So from a protection point of view, these two schemes seem to be equivalent. And also from a repair rate point of view, they produce the same overhead from a bandwidth perspective. So which one is the better one, which one to pick for certain situations? So if you take the next slide, if you look at something like uniform traffic, so what do I mean by that? In the figure here, we gave every symbol a different color, indicating that they arrive at different times. We also put a deadline, which means that they expire after 80 milliseconds. So in this case, every symbol arrives after 10 milliseconds and expire after 80. So you see that symbol number 1 will expire when symbol number 9 arrives, indicated by this sort of dashed gray line, right? And what you can also notice here is that the distance to repair is minimized, right? We have sort of shrunk down. We're generating repair as quickly as possible for this specific repair rate. So there's no way that we can move the repair closer to this or sort of we've spread out the repair uniformly in all the symbols, right? Sorry, in all the symbols. And they get the same protection. All of them are still covered by 4 packets. And the latency penalty of losing symbol 1 is 10 milliseconds because R1 is generated directly after S2. If you then take the 4,2 repair pattern under the same, on the next slide, on the same under the same conditions, if you move to, if you then take the sort of the other repair pattern, you will see that we have the same protection here, but we are not minimizing the distance to repair. So actually what will happen is that if we lose the first symbol S1, we actually have to wait 30 milliseconds to generate the repair and fix that packet loss. So for this type of and this was sort of our intuition, was that sort of spreading the repair sort of equidistantly out in the stream would be the best, because we would then minimize the distance to repair from a latency perspective. But what is interesting is what happens when we actually look at something like a bursty traffic pattern. And if you take the next slide. So here you see that we have the first 4 symbols. They actually arrive at the same time. So this could be a video frame consisting of 4 network packets, for example. And now it's all the same, but in real applications, of course, the video frames would be sort of made out of different amounts of packets. But just for simplicity, every frame here is 4 packets. When we do it this way, when we do the 2,1 repair pattern, which sort of for the uniform case looked like it was the best one, we actually see that the symbols S3 and S4, they are not protected as well as S1 and S2, because they expire before R5 is generated. And in the uniform case, R5 would also cover S3 and S4, but in this case, because they arrive as a group of packets, they also expire as a group of packets. And therefore this this way of doing the repair actually means that we get less protection when we have the repair packets interleaved within the block of packets. The latency penalty of losing S1 is 0 milliseconds approximately, because we generate the repair right after receiving these 4 packets, which arrive at the same time, and we generate the repair instantaneously. Of course, there's some computational overhead and all this, but from a millisecond point of view, that doesn't matter much. If we then look at the 4,2 case, what is interesting is that actually, on the next slide, that in this case we still have the same sort of distance to repair, right? Because the 4 packets arrive at the same time. But now R1 and R2 both cover all 4 packets inside the frame, which means that, and if you then look at the columns again, you can see that now everybody is covered by 4 repair packets again. So essentially, this seems like a better pattern for bursty traffic. And if you go to the final slide, so what we sort of discovered was, sort of to summarize a little bit, that if you have uniform random traffic, it makes sense to try to minimize the distance to your repair in order to minimize the latency at the decoder. But if you have bursty traffic, like a video feed coming from a camera, for example, it actually makes more sense to make the sort of the coding follow the bursts of the traffic in order to maximize the protection of the symbols that you're transporting. And if you want to read a little bit more about it, we wrote some stuff about it on both in some documentation for one of our coding libraries, but also on our blog, where we talk about something we call content-aware coding, which is really if you know something about the structure of the content that you're protecting, you can utilize that knowledge in your FEC scheme to actually make the best possible protection, and you have to do that if you want to get the best possible protection. And if you want to get in touch with me, you can reach me on my email, or you can visit our website, which also has some links to contact us and for further discussions. But yeah, so just wanted to share this observation, because it sort of surprised us a little bit when doing the work, that actually we were sort of off in our understanding of what was the best repair pattern and the best way to use the FEC. So thank you very much for your attention.
Thank you, Martin, for this presentation. Yes, it's quite interesting because it's more complex than what we would think, deciding how to split, interleave all those repair packets with the source flows. There might be several flows as well. It's not that trivial, so very interesting. We are running short of time, sorry for that. We are obliged to very quickly stop this session. But I suggest we continue on the mailing list. Do you want to add something, Marie-Jo? Or anybody else?
I'm sorry, my audio was off. No, I think it's a good idea to continue for sure on the mailing list, especially as regards the open documents. Again, thank you, Morten, for the presentation. And yeah, we're going to be cut off in 1 minute. So I guess now that I'm fully awake, I don't know what do you do in Montreal at 3:30 in the morning? If anybody has an idea, maybe I'll just read something. Thank you.
Thank you, everybody. So yes, let's continue. We have quite a few important questions to address on the list regarding the various documents and calls in particular. Goodbye.
Bye, everyone. Have a great day.